Hello students and welcome to the next module of conditions of path difference for interference. Students, in this particular module, we'll be studying the conditions of path difference for constructive interference. If we go ahead, first let us consider a wave traveling along the positive direction of x-axis. Now further students, we'll name the points. O, which is the origin, and further if we go, every point touching the x-axis is going to be A, B, C, D, E respectively. Further if we go students, if you clearly see the distance between point O and point A is lambda by 2. That is nothing but half the wavelength students. Further, what will be the distance between point B and point O? 2 lambda by 2. But why to write 2 lambda by 2? 2 and 2 gets cancelled. Students, we are going to deal with the multiples of lambda by 2 just to simplify or get a standardized case. Let us go ahead. Distance between point O and origin or point C is going to be 3 lambda by 2. Similarly students, for point D and point E, it is going to be 4 lambda by 2 and 5 lambda by 2. Now students, let us analyze the same diagram thrice from the point of view of interference. So we'll have the same diagram getting repeated thrice. Now on the first diagram, if you can clearly see, we have another wave starting from point O as shown. Now students, can you clearly see the crest is coinciding with the crest? Also, both the waves are starting from the same point. That is why can I say the path difference is going to be 0. Path difference 0. Crest coincides with the crest. So very clearly students, constructive interference takes place. Let us analyze the second diagram. Now in this particular case, our wave is starting from point B. Very clearly, the path difference is 2 lambda by 2 because there is a difference between the starting point of the two waves. Now students, in this particular case, if you can clearly see, once again, the crest is coinciding with the crest and therefore we get constructive interference. Let us have a look at this third diagram. We have a wave starting from point D. In this case, the path difference is going to be 4 lambda by 2. Once again students, the crest is coinciding with the crest and we get constructive interference. Now students, let us analyze these three cases. Case 1 says path difference is 0. Case 2 says path difference is nothing but 2 lambda by 2. Case 3 says the path difference is going to be 4 lambda by 2. Now if you very clearly see students, 0, 2, 4, apart from 0, 2 and 4 are even numbers. So very clearly students, when the path difference is n lambda by 2 and n is an even multiple, say 0, 2, 4, 6, etc., we get constructive interference. Let us quickly go ahead students and find out the relation between path difference for destructive interference. Consider a wave traveling along the positive direction of the x-axis. Let us have our points named exactly the same way. Now we'll be marking the distances one by one. So first between point O and point A we have lambda by 2, and as we go ahead between point B and point O we have 2 lambda by 2. Between point C and point O we have 3 lambda by 2, and similarly for point D and point E it is going to be 4 lambda by 2 and 5 lambda by 2. Let us analyze the same diagram thrice once again students. First wave starting from point A. Students, there will be a path difference, right? The path difference is going to be the distance between the starting points of the two waves, that is lambda by 2. So students, if you carefully see, once again, the crest is coinciding with the trough. Path difference is lambda by 2 and that is why students, destructive interference takes place. Further, if we see the second diagram, wave is starting from C. So the difference between the two waves becomes 3 lambda by 2. Once again, crest is coinciding with the trough and that is why students, we get destructive interference. Let us go ahead students for the last wave, that is the path difference is 5 lambda by 2. Once again, crest coincides with the trough and we get destructive interference. Let us analyze these three cases again. Case 1 says path difference is 1 lambda by 2. Case 2 says path difference is 3 lambda by 2, and case 3 says path difference is 5 lambda by 2. Once again, if you very carefully see 1, 3 and 5 all odd numbers. So students, when path difference is n lambda by 2 and when n is an odd multiple, say 1, 3, 5, 7, we get destructive interference. This knowledge, students, will be very helpful in understanding the next module. Thank you. I'll see you for the next module.